Okay, we're on our final type of graph for our purposes, even though we know there are more than 4 types of graphs. So we have already discussed bar graphs, histograms, line graphs, and then we said our last type of graph would be a scatter plot. Okay, so scatter plots are a little different, and you're going to be seeing and hearing about these in math. In fact, part of what we talk about, I bet, will sound familiar in some ways. So a scatter plot, I'm going to start with the purpose of a scatter plot here. So a scatter plot is to show a relationship or, here's the science word, correlation. Now correlation, if you notice, has the word relation in it, like relationship. So correlation means it shows a relationship among other things. Co means working with something, right, like a co-worker. So a relationship they have with each other, correlation. So it shows a correlation. However, I want to caution you, correlation does not always mean cause and effect. Now you may be able to test out whether one thing causes another, but you can definitely see if there seems to be a relationship between those items. And I'll give you some examples later of why we don't assume that there is a cause and effect relationship. So with scatter plots, you are trying to determine if there's a relationship. So you basically, when you read a scatter plot, you come out with one of 3 conclusions. First, you could be able to see a strong correlation. You could be able to see a weak correlation. Or there may be no correlation at all. Okay, we can pause so you can catch up. So you still on a scatter plot, we're going to draw like 3 tiny graphs here. We're going to have 3 tiny X and Y axes. Okay. And you're going to hear Mr. Stevens talk about the line of best fit when we talk about a scatter plot. And so I'll kind of give you, show you what that means. So on a scatter plot, if something has a strong correlation, it means the X and Y axis have some sort of pretty close relationship that causes every time you go up on the Y, you kind of go over about the same amount on the X, right? Up on the Y, over on the X. And so you're moving at a pretty steady interval, which ends up causing something real similar to a straight line. So if we drew a straight line through here, we could see that this has a pretty strong correlation because those dots end up on pretty much a straight line, okay? And it doesn't have to always be in the positive direction. It could be negative, like if you were on a good weight loss plan and what you ate and what you exercised might help your weight go down, whatever. So that would show a strong correlation. A weak correlation would be that the dots kind of, indicate a line, but they're not very tightly grouped. So when we do that line of best fit, we don't have as many of the dots falling right on the line. We've got them kind of grouped around it, so it looks like there might be a correlation, but it's not a really good strong one. And then no correlation on a scatter plot, you've just got dots scattered everywhere. There's no, nothing is sticking to that line of best fit. You don't really have those grouped really tightly around it. You just have dots kind of scattered amongst. So again, this shows a relationship, but it does not tell us necessarily that one thing causes another. We just see that they interact in some way. So that's important for you to know the difference.